All right, you are all welcome. Okay, all right, I'll be sharing my screen now and we will begin. Okay, you are all welcome to JP Smart Solutions Limited. We are actually thrilled to host this training session on power system design, analysis, and protection. So, these are the services we offer. Of course, power system design, analysis, and protection, engineering project development, procurement of technical equipment, trainings and certifications, which we are doing now, and of course, technical services. So, once again, you are welcome to the 14 days masterclass on power system design, analysis, and protection held by JP Smart Solutions Limited. My name is Ekwe Jesse, and I am an electrical engineer with a vast knowledge on power system design, analysis, and protection. As an experienced professional, I have worked on various power system projects ranging between low, medium, and high voltage levels. In this series, I will be taking you on a 14 days masterclass on power system design, analysis, and protection using ETAP software. So I will be teaching you on how to transition from an absolute beginner to a specialist or a professional in power system design, analysis, and protection. As we earlier disclosed through our social media handles, the first 2 days of this training will be entirely free. Now, to get the link for tomorrow's training, kindly send us a message via WhatsApp and you will be added to our platform and the link will be dropped on our WhatsApp platform. Send us a message via WhatsApp using this number and you will be added immediately. So let's look at a brief outline of what this course entails. Firstly, we have the Module 1. The course is actually divided into 6 modules. Module 1 is an introduction to power system design, analysis, and protection using ETAP software. Now, this Module 1 entails the basics, which are the concept of power system design, concept of power system protection, then also the concept of ETAP software and its application to power system design, analysis, and protection. Then we move over to Module 2, which is the modeling of electrical power systems. Now, this section contains the concept of power system modeling, an introduction to single line diagrams, basics of ETAP software, and also hands-on exercise where we are going to be modeling a primary distribution network using ETAP software. Next, we have the Module 3, which is for power flow analysis on electrical power systems. And this section entails the concept of power flow analysis, the objectives of power flow analysis, the methods of power flow analysis, and most importantly, a hands-on exercise which involves power flow analysis of a primary distribution network using ETAP software. So we are going to be showing you how to carry out the analysis and most importantly, how to interpret the results obtained from the analysis. Module 4 is all about voltage regulation and power loss minimization. So of course, we are going to be discussing the concept of voltage regulation, the methods of voltage regulation, the concept of power loss minimization, the methods of power loss minimization, and we are definitely going to have a hands-on exercise on voltage regulation and power loss minimization in a primary distribution system using ETAP software. Next, we have the Module 5, which is short circuit analysis on electrical power systems. Now, here we are going to discuss the concept of electrical faults, the classification of electrical faults, the concept and types of a short circuit fault, and we are going to have 2 hands-on exercises. The first hands-on exercise will be the short circuit analysis of a power system using ETAP software, and the second hands-on exercise would be on hand calculation of short circuit analysis. So we are going to carry out an analysis on the power system, short circuit analysis, then carry out manual calculations and compare the results generated from our manual calculations with ETAP software. And finally, we have Module 6. Now, Module 6 is electrical power system protection. Here we are going to be discussing the concept of power system protection, the essential qualities of a protective relay, protection zones in a power system, protective schemes in a power system, which gives us 3 sections of Module 6. So Module 6, we are going to be having overcurrent protection scheme, differential protection scheme, and distance protection scheme. So on overcurrent protection scheme, we will be taking the concept of the overcurrent protection scheme, and then we also have hands-on exercise where we'll be designing an overcurrent protection scheme for motors and cables using only circuit breakers. We are going to also design an overcurrent protection scheme for motors, cables, and transformers using overcurrent relays. And lastly, we are going to carry out relay settings calculation as well as relay coordination under overcurrent protection scheme. Then we move on to the B part of Module 6, which is for differential protection scheme. So we are going to be explaining the concept of a differential protection scheme, and we are also going to have 2 hands-on exercises. We are going to design a differential protection scheme for a 5 MVA transformer, and we are going to design a differential protection scheme for an 11 kV bus bar. The final part of Module 6, which is Module 6C, is the distance protection scheme. Here we are going to be talking about the concept of a distance protection scheme. We are going to also introduce the concept of a 4-stepped distance protection scheme, and we are going to be carrying out a hands-on exercise, which is the design of a distance protection scheme for a 132 kV transmission line. That is basically the outline for this course. Then we come to an end and conclude the session. So let's begin with Module 1. We have power system design, analysis, and protection. So what is a power system? An electrical power system is a network of electrical components which are interconnected with the primary aim of generating, transmitting, and distributing electrical power. It is a network of electrical components which are interconnected with the primary aim of generating, transmitting, and distributing electric power. So basically, a power system is made up of components or equipment such as our power plants, our transformers, our transmission lines, our bus bars, our switch gears, induction motors, synchronous motors, capacitor banks, and etc. So when we talk of power system design, now power system design is the technical and strategic process of creating an integrated network of electrical components and systems that generate, transmit, and distribute electricity to meet the present and future energy demands. Now, observe there are 3 key factors. It must be generating power, transmitting power, and distributing power. That is a power system. So when we now move further to talk of power system analysis, power system analysis is the study of the behavioral operation of the power system under various conditions, configurations, or scenarios. Various conditions, configurations. Now, what if this generator is isolated? What if these loads are not connected? What if this tiebreaker or bus coupler is open or closed? Those are different scenarios, different configurations, different conditions. So we are studying the behavior of the power system under those different conditions. That is power system analysis. Then we come to power system protection. In power system protection, it is the art of employing a mechanism in order to ascertain reduction in the effect of a fault occurring in the power system network. Now, if you recall, basically in electrical power systems, it is impossible to have a system which is totally free from fault, which means that fault must occur in your power system. So power system protection is all about trying to reduce the impact of that fault in your power system. So let's move to an introduction of ETAP software. Now, what is ETAP software? ETAP is basically an acronym for Electrical Transient Analyzer Program. I'll take that again. Electrical Transient Analyzer Program. Now, ETAP is an analytical engineering tool or software which aids an electrical engineer to design, simulate, and analyze the steady state and transient or dynamic state of a power system. It is also used in various sectors such as generation, transmission, distribution, industrial, and transportation sectors. Now, when we talk about capabilities of ETAP software, ETAP software can be used to create a digital twin of a power system. That is, creating your one line diagram or your single line diagram on the software. It is also used for load flow analysis, short circuit analysis, arc flash analysis, transient stability analysis, optimal capacitor placement, protective design and coordination, protective device design and coordination, reliability assessment, contingency analysis, motor starting analysis, intelligent load shedding, and much more. The software is basically packed for power system design, analysis, and protection. So let's move on to the actual business of the day, which is Module 2, modeling of single line diagram. So the first question comes up, what is a single line diagram? Now, a single line diagram is also known as a one line diagram, and it is the most basic type of electrical installation blueprint which uses a single line and standard symbols to represent all three phases of a power system. A single line diagram, basically it provides a high level of information about our substation or our power plant or basically any switch gear. Whenever you want to start a new project or you want to start a construction, the most important document that is there to support you is your single line diagram. So a single line diagram is a simplified way of representing a power system, simply put. Now, the primary purpose of a single line diagram is to supply concise form, in concise form, significant information about the power system. The importance of different features of a system varies with the problem under consideration, and the amount of information included on this single line diagram is dependent on the purpose for which the single line diagram is intended. Let me explain with an example. The location of circuit breakers and relays in a power system is irrelevant while performing a load flow analysis. So circuit breakers and relays are not shown on the single line diagram if the primary function of that diagram is to provide information for such a study. However, in the determination of the stability of a system under transient conditions resulting from a fault, it depends on the speed with which the relays and circuit breakers operate to isolate that faulted part of the system. So this information about the circuit breakers and relay configurations will be of extreme importance for such a study. Therefore, they are required on the single line diagram. So a single line diagram is basically prepared depending on the reason for preparing the single line diagram. Now, in summary, a single line diagram is a part of the initial stage in electrical designs. A single line diagram is used for basic reference by management and engineers for planning and costing phase of any project. A single line diagram provides a basic roadmap to the interconnections of the electrical system and serve as a building block on which all type of system analysis are based. And lastly, it is mainly used for working out panel schedules, load schedules, fault analysis, and protection system design. The information found on a one-line diagram must be expected to vary according to the problem at hand and according to the practice of the company preparing the single line diagram. Now, on ETAP software, we have two standards for modeling of single line diagrams. The first standard is the ANSI standard. And ANSI is an acronym for American National Standards Institute. The second standard is the International Electrotechnical Commission, IEC. These are the two standards available on ETAP software. And now, the American National Standards Institute operates on the frequency of 60 Hz, and it is also known as the English unit system. While the IEC is also known as the metric unit system, and it operates on the frequency of 50 Hz. So the difference is ANSI is also known as English unit system, and it operates on 60 Hz frequency, while IEC is also known as metric unit system, and it operates on 50 Hz frequency. So we are going to be taking an example on single line diagram. So I would be opening ETAP software. At this point, we can entertain questions. You can send questions in the chat and we will respond to questions immediately. Okay, let's check for questions. All right, seems there is no question. Okay, so we proceed. All right. Okay, is the ETAP software free or does it have a crack? If so, share the link. Okay, the ETAP software will only be shared to those who continue the class. That is, the first 2 days are free, so everybody can actually participate. But once you register for the remaining days of the class, then we would actually be sharing you ETAP software. Okay, Since you said the first two lessons are free, does that mean we need to pay going forward and how much? Yes, going forward, the price of the cost of the training is $100, 100 USD. For the first 2 days are going to be entirely free, so you can decide to continue after then or not. Also, certificates will be issued for the first 2 days for the participants because we're going to give exercises as we mentioned. There will be hands-on exercises, so that qualifies you to get a certificate after the training for the first 2 days and also for the 14 days. Are you planning to add a flash model? Okay, so for Act Flash, we can actually do that in a later training, but this particular training for 14 days has been constructed and carefully planned without Act Flash model. Okay, one more question before we continue. All right, in the absence of questions, we will proceed. Now, when you open ETAP software, this is ETAP version 24. This is what you see. You can see ETAP version 24. In order to create a new project on ETAP, for you to carry out any analysis, any design, any protection scheme, you must create a new project or it will be an existing project. But for this case, we are going to assume you do not have any project, so we are going to be creating a new project. Now, I'm going to be walking you step by step on how to create a new project and what everything means. So first, we come over to File, we click on File, and these are existing projects that I have worked on. But for your first time, you can click on New to create a new project. Now this comes up, and the first thing we see is the project file name. Project file name. Here we can enter the name of the project we want. So maybe 14 days MC Masterclass 1. This is the name of the project. Now, here we have the directory. Directory basically shows the location of the project file. That is where this project file will be saved. And this can also be, it can always be modified or changed to any location you wish just by clicking on browse over here. Next, we have the unit system, which I explained earlier. Now, we have the English unit system and the metric unit system. And from the explanation I gave earlier, the English unit system is also known as the ANSI system, which is the American National Standards Institute, which operates on a frequency of 60 Hz. While the metric unit system is also known as the IEC standard, and it operates on the frequency of 50 Hz. So depending on the project requirements, you select your unit system. For the purpose of this training, we are going to be using the metric unit system, which is the IEC, and it operates on the frequency of 50 Hz. Next, we have the password. Now, for password, you can check required, that is checking this box, to assign a password to this project file being created. So whenever you want to open the project file, you enter the password. Now, the default database of ETAP software is SQL. That is the default database. So that is basically what this dialog box displays. Next, we click OK. And another dialog box will pop up. This is for user information. Now, in this section, you can input the username, the full name of the engineer, and the email. Now, please note that this information is not compulsory in order to create a project file, which means that we can just skip it and click OK. And the last dialog box pops up. Now, This dialog box basically is for access levels. As we can see, select access level. Access level. Now we have various access levels such as administrator, project manager and editor, base editor, revision editor, checker, and the likes. Now let me explain the function of each access level. For administrator, as an administrator, you can add new users or you modify the existing users for this project. That is giving access levels. You as the administrator give access levels for the project you are creating. As a project manager and editor, you can edit both base and revision data. You can also edit library parameters as a project manager and editor. But as a base editor, you can only make modifications in the base revision data. Next, we have the revision editor. Similarly, as a revision editor, you can only edit revision data. Then we have the checker. Now, as a checker, your job is just to check and validate anything relating to the project file, which means you are not changing anything. You're not authorized to change any information on this project. You're just authorized to check and validate, okay, this is there, this is not there. That is the work of a checker. Then, as a browser, now you go as far as checking and browsing base revision data. However, you will still not have access to any edit capability. You will still not have access to any edit capability. Okay, now we have the librarian. Now, as a librarian, you can only control or edit the library parameters for various electrical equipment on ETAP software. You can only edit library parameters. You know, ETAP has a vast library of equipment from different manufacturers, your equipment such as your cables, your motors, your transmission lines, your transformers, a vast library. So your job as a librarian is only to edit those library parameters. You can even create your own library parameter on ETAP software. Next, we have the controller. Now, as a controller, you can access control system settings and status or online monitoring mode. That is the job of a controller. Online monitoring mode. And lastly, the operator. Now, as an operator, you are only monitoring the online data and simulating the system operation. So the difference between controller and operator, controller is just monitoring. Operator is monitoring and simulating the system operation. Now, for all the new projects created on ETAP software, the default access level will be selected as project manager and editor. Unless you decide to change this, this will be the default. So we can click OK. And our file is being created. Okay, takes a while, but then it will come up. Okay, now we have the software loaded. Now, once you have created the file, you are ready to design, model, analyze, your power system. This is what pops up. I'm going to be explaining what you are seeing on the screen, but let me verify if we have some questions before we proceed. Okay, let's see. Okay. All right. You don't have this version of ETAP. Will you provide us the presentation for these videos? Yes, the videos will be uploaded. The videos will be uploaded on, and the link will be shared on our WhatsApp platform. The link for the videos will be shared on our WhatsApp platform. Is there for WhatsApp version for this app? Where can I find? Okay, for ETAP version 24, for ETAP version 24, for ETAP version 24, you can simply contact us and we will actually share the software with you, but it is at a cost. Because then is there the ETAP 24 interface is nice. Oh yes, thank you so much. Now let's proceed. So we have a few minutes. All right. So basically, today's session will be all about just the overview of this. Tomorrow, we are actually going to carry out the modeling of a power system network. And now, over here, we have what we call the toolbars. This first one is the edit or model mode. This gives us the ability to actually design or model our system. So as you can see over here, we have edit equipment. This is our AC equipment. We have the bus bar, node bus. This is our transformer. We have transmission line. We have generators. Now, the beautiful thing about ETAP is this. Even if you do not have a good foundation knowledge on single line diagrams, on interpreting single line diagrams, you don't know the standard symbols. The moment you take your cursor over to any equipment, it pops up the name of the equipment. So, assuming I don't know this is a transmission line, I bring my cursor over here and I'm saying, okay, this is a transmission line. So, if I have to model a transmission line, I know that, okay, I have seen the transmission line. So, we have our AC equipment over here. We also have our instrumentation equipment. We can see our current transformers, our potential transformers. We have our AC control power, voltmeter, ammeter, overload relay. See our relay section over here. We have our overcurrent. We have our distance relay. We have a multifunction relay. We have differential relays. We have overload relays. So we have a lot actually over here. But then ETAP is not stuck on AC equipment. We also have DC equipment and we have converters. We have over here our UPS, our VFD, we have our charger, we have our inverters. So we have DC equipment. Just as we have AC equipment, we have our DC bus, we have our DC cable, we have DC composite networks, DC loads, lump load and static load. So these are all our edit equipment. So these are the equipment we use to create our single line diagram. Next, we have the modes. Now, as I explained earlier, this section is for the mode toolbar. We have the load flow group, the short circuit group. Now, basically, we are going to be exploring these sections as we progress in this training. As we progress in this training, we'll be exploring load flow, how to carry out the load flow, short circuit and protection, and all that. So that is basically for this part of the software. These sub parts are basically just editing functions. As you can see, this part is to check circuit continuity. So when you model your single line diagram, you want to know the parts that are live and the parts that are not connected to power. To check circuit continuity, highlight the parts that are not connected to power and separate it from the parts connected to power. This is span basically to move around your drawing if you have a large drawing. So these are basically actions we can use. We have a dumpster, very important. Just as your PC has a recycle bin, when you delete something from your PC, it goes into the recycle bin before being permanently deleted. Now, ETAP also has that feature in case you accidentally delete an equipment from the single line diagram. So once you delete it, it moves into the system dumpster. It's not permanently deleted, so you can actually go to the system dumpster to retrieve it and continue your work. Now, it should be noted that you can only add or remove equipment which have been modeled when you are in the edit mode. Meaning for you to include any equipment on your single line diagram, this is our workspace. To include any equipment on our workspace, we need to be in the edit mode. If we are in the power flow mode, we will not have access to that. For example, if I click the power flow mode now, just as I did, we no longer have access to our AC DC instrumentation equipment. But if we come back to edit mode, then we can have access to that. So to add equipment on our workspace, we only use the edit mode. Likewise, after modeling, if you want to remove an equipment, you must also be on the edit mode. As we explained, single line diagram is the building block of all forms of analysis. So it is on this edit mode we can build our single line diagram. So these are basically to three-dimensional database. We have our presentations, we have our composite, and we have our configurations. Now, basically, we'll be exploring this in our training. So, but as I explained earlier, under different configurations, different scenarios, various conditions, this is where it comes into play in the configuration manager. At this point, we have the ability to change the status, the operating status of equipment, such as circuit breaker. We can change it, okay, in a particular configuration, let these breakers be open. In another configuration, let these breakers be closed. Then we put them side by side, and in order to put them side by side, we are going to use the presentation. It's more like going to split our screen into two, and on this side we have the circuit breakers that are open, and on this side we have the circuit breakers that are closed, and we run a power flow analysis on both sides, looking at the differences, the effect of each configuration side by side. That is the use of this. So here we can actually change the color, this contrast. We can change the color of our workspace if we want. We can use the default. And at this point, we can do basic color coding. Okay, for 11 kV, it should be displayed green. 33 kV of this system should be displayed blue and all that. So that's just basic color coding. So that's basically an overview of ETAP software. All right, so we are actually done for today's class. We'll take some questions. So tomorrow we can work on single line diagrams. Let me verify the questions. Okay, someone is taking notes. All right. We have the SLD on alpha. Can we import it to ETAP and save the time of modeling? No, on the contrary, you cannot import that to save the time of modeling. You still have to model the system for CAD files. Now, basically, on ETAP, we can actually collaborate. But now, this collaboration is for data exchange. It's not for the actual modeling. It's not for the actual modeling. All right. The ETAP that we've shared for in the masterclass, is it version 24? No, the ETAP shared in the masterclass for free is version 21. For version 24, it costs $200 only. Now, will you provide the recording for this class in video format along with presentation? Okay, for the recordings will be sent each day, while the presentation will be sent at the end of the class. That's the PowerPoint presentation. So, one last question before we conclude. Does ETAP 24 allow me to use a file saved in previous versions such as 19? Yes, definitely it does. The only thing is that once you have saved the file on version 19, once you save the file on version 24, you cannot access it on version 19. But if you save a file on version 19, you can definitely access it on version 24. So, once again, thank you all for participating in today's session. Remember, send us a message on our WhatsApp to get the link for tomorrow's training. This is our WhatsApp number over here. Send us a message, you'll be added to the platform, and the link will be shared for tomorrow's training. Do enjoy the rest of your day.